Well, welcome to the September 1st, 2018 Structural Modeling video conference. Today we're going to be talking a little bit about the background and context of open source structural modeling software. There's a technical report 24, which is out on our ResearchGate site. Has all our technical reports are out there. And today, basically what we're going to do is just talk about the different types of logical relationships and the different types of software functions and software logic that need to be implemented to take advantage of the sources of knowledge within a group. And the sources of knowledge within a group can basically, the fundamental source of knowledge, of course, is you're asking people, you're asking experts, you're bringing them together to make sure that you understand the situation. And then the other source of knowledge is when you're structuring the information you're getting from the group, whether or not you put them in, you can structure this information in such a way that you can take advantage of logic to infer information that you won't have to ask the group from, that you can infer those from. And we start out by looking at the GMU ISM software. We've looked at quite a bit, and it's basically a type of software that was produced by John Warfield, a DOS-based system. It was closed source software, but there's a handbook and there's a manual and instructions on how to use it. So we did a bit of analysis and then created some open source software that emulates and produces those same types of functions. Once we had that software running, and we also actually took a running copy of the GMU ISM software and put those both, and went back and identified and published examples of people that worked on ISM activities and structural modeling activities, and we were unable to consistently reproduce the structures that were published in the literature. And we started looking at that, and we believed that one of the problems we ran into was that the natural language relationship was being used may not be strictly determinate outcome given the software function. So what we did was we actually went through and developed the AMEI, which is Augmented Model Exchange Isomorphism, and looked at that. And we basically did the Augmented Model Exchange Isomorphism so we could talk about logical reasoning and logical property groups of natural language relationships. And one of the more interesting things about the structural modeling, and in one of the preface to one of the Patel Memorial Institute monographs, Warfield wrote that he described structural modeling as an approach to organizing thoughts about systems with the assistance from a computer. And this approach can help people who consistently seek to apply logical reasoning to complex problems and communicate their reasoning fully to others. And it's a proposed logistical apparatus to enable them to do so more effectively and efficiently. And so really what the AMEI does is it kind of helps us in the logical topology and say, well, where can we realistically apply the logical reasoning? Does it apply everywhere? Does it only apply in certain places? Where does it apply? And how does it apply? So we looked at these things and found some interesting results. We are kind of handicapped, though, by the fact that the software was closed source. So we just had to infer the operation from like a black box testing and analysis of the software. And so what we did looking at the Warfield's publications in his literature, he came up with the logical relationship groups that he addressed. Now, he didn't address, definitely required that all the relationships be transitive as a propagating type of relationship. But in other cases where he listed the prose logical relationships, he did that very sparse about that. Didn't really write a lot about what the logical relationships were in prose, but he demonstrated it quite often in graphics. So we took and integrated the prose and the graphics together to come up with the areas where we believe the original structural modeling relationship groups are. And they're all here in the first column. They're all transitive, but they're reflexive, symmetric, and transitive, and irreflexive, symmetric, and transitive. Most interesting thing there is that Warfield said reflectivity and irreflectivity, really, you can change them as you will because they only apply to one object. They really don't apply to two objects. And so you can change them and it won't affect the system structure. You can kind of work with those depending upon how they impact your natural language relationship. We decided to go ahead and to be a little more rigorous about that and to do all the 27 permutations, of which we've listed in the MEI. And of course, these are the logical property groups that were most addressed within the classical structural modeling analysis activities. They're rather interesting, but it's also rather constrained. So, and there is some uncertainty associated with the reflexive property, as I talked about, because it only applies to one object, and how does that apply to a system? You need to have a series of rules that addresses that. And we've come up with just a set of objectives or kind of guidelines that we use. And we do that by taking a natural language relationship and then asking a simple question. So I think one of the things that's kind of missing in the structural modeling approach working with a large group is we really need to have some very simple tests of people in the group where you ask them questions about the logical properties of the objects that they are addressing or working with. And that's kind of a mapping, kind of a viewpoint mapping that I think is really necessary to increase the effectiveness of a structural modeling type of activity. And as we talked about in the before, in the idea of the differences in graphical languages between object-oriented and functional IDEF views of the same system, that some people are naturally predisposed to see things one way or the other. And they're both of those languages are either UML or IDEF or computer executable. And so if you, again, had a way to map the processes by which people see these things naturally, then you could present those graphical information to them in a way that is most natural to them. You wouldn't be requiring that everybody in the group has to see everything the same way, because you could then test the individuals to see how they naturally see things and then adjust their view. And I think that's the same, similar to the logical property. And so the transitive piece, of course, is the idea where you have propagating relationship, but then the idea of propagating global scope. So what does that mean? Does it apply to everything? And we'll see here in a minute that we have some very common natural language relationships that are local, and we have to have some that are global. And we'll look at the graphics and the mathematics and determine why that's important. And of course, the ones that are local are like what influences B and what is part of B. And part of the course is not global. Everything is not a part of everything. So it's local. There's some local relationships there, but there's some interesting aspects of how we actually look at this, and we'll talk about in a bit. And then part of is kind of got one or two groups, logical groups that would fit in. Influences, though, is a little more dispersed. It can fit in any one of the 27 logical groups, and you would, and so that again is a little more challenging. And so part of and precedes examples here. We'll just kind of walk through the natural language structure and relationships as part of.
Joe, can I ask a question? If so, influences sometimes not transitive, or is it always transitive?
Influence cannot be, it can be anything. It can be transitive, it can be non-transitive. You can make a decision, right? But in the natural language relationship, if you have a large group of people and you ask people about influences, you probably get, a large number of different answers. And so it's kind of very dispersed. So it can be or not, right? Now to apply the classical structural modeling approach, it's required that it be transitive, right?
Right. What I was wondering was at the natural language extreme, people could use the words to mean whatever they want them to mean. But I was thinking that if A influences B, once one has gotten to a logical relationship of A influences B and B influences C, then what's an example where A does not influence C by the mediation of its influence on B? Or are there, but I guess what are the trade-offs of saying either that influences in a logical relationship is necessarily transitive, or it could be intransitive?
Yes, and so those are very good questions. And what we designed the AMEI to do was to talk about those things in detail. Mm-hmm. And if you had a group together and you were, let's say, for example, you were talking about we're going to use influences as a natural language relationship, that's what we're going to do. And then you would ask them these things. And that would be part of the calibration process, right? And so, so that would be, and you would have a discussion about that, of exactly what the logical properties mean, how this mediation through a different object would work. Right. So those are the things that you would actually, that the AMEI and the concepts of global and local would allow you to discuss in a little more detail.
Right.
I think you have to be careful here. There's a difference between the logical view of this situation and the computer programming view. John was not able to deal with all of the relationships that he was aware of because the programmer couldn't write an ISM tool that dealt with that level of logic. So what ISM will do for you or not do for you is unfortunately heavily constrained by the kind of code that they knew how to write way back then.
Okay, that's really a good point. So it's kind of an aside here, but I'll go down this aside anyway. But so,
and therefore you should notice that John was very, very intent, for example, particularly on the influences relationship, that the adjective significantly always be used.
Mm-hmm.
Except that people didn't know what one guy's significantly wasn't the same as another guy's.
Mm-hmm.
Right.
So back looking at the time when this mathematics and software was being developed, I went back and I looked because I decided that basically what it turns out to be, the implementation turns out to be a binary search.
Yes.
So I started looking for examples in the literature of when people started publishing the concept of a binary search in software, right?
Yeah.
It was about the same time. So when they were working on the software and they were doing it, it wasn't a well-known, well-defined concept in computer science.
Right.
And so when when I looked at it, I said, well, why didn't they do a binary search here? One reason that they didn't do it is computer science hadn't really developed that concept and everybody hadn't agreed on it yet. And so I think that's a good point, is that they were constrained by those things. And algorithms that we take for granted today hadn't been developed then.
And about that same time, along came Zeta with his fuzzy logic ideas. And unfortunately, everybody was going their own path so fast that they didn't take time to go cross-correlate their ideas.
Yeah, it is. So that's kind of that part of it. The other part of it is, I think it's very important, I think that Janet brought up, is how do you make sure that people all have the same kind of idea about what these logical things are? And I think that's a kind of a set of tests that could be developed by psychologists to fairly easily identify fairly quickly where people are. Just a few questions, few answers, few pictures. But those are things I think it would really help in normalization. But so now back to the part of and the precedes examples.
Yeah.
Just going here and just looking at the idea of neurology or neuronomy and part of. I looked up some of this information, and so they say part of is reflexive. Everything is a part of itself. And so this applies to only one object, but it implies if you only have one object that a part is the whole. And so when you're talking about the difference between the whole and the part, right, this kind of confuses the idea of, what is the concept of a whole and what is the concept of a part? So if you allow it to be reflexive, there's some uncertainty there. And antisymmetric, nothing is a part of its parts. And essentially, this is asymmetric if you don't allow the reflexive piece, right? You don't allow the qualities or the identity that a part is equal to itself or a part is identical to itself as a whole. You eliminate that part, then the antisymmetric reduces to asymmetric. And then, of course, let's see, transitive. Parts of parts are parts of the whole. So we look at this, we find that the concept or the idea of assigning a reflexive property to part of introduces uncertainty. So we acknowledge that, and we say that if you use irreflexive, it reduces uncertainty, reduces complexity, and probably is what you're really is the closest logical representation of what you're talking about. So we went through and looked at that, and we believe that by saying that a part of is irreflexive, asymmetric, and transitive makes it more closely aligned with the real world engineering level type of things that we're dealing with, or social type of organizations that we're dealing with, the social technical organizations. And finally, the last thing about allowing part of to be reflexive is it really adds no information. I mean, if you say A is identical to A, that adds no information at all. And so you're adding computational complexity, you're adding cognitive complexity for no benefit, because you're just keeping track of the fact that A is A. And that's pretty much well known.
Joe?
Hello?
Yeah, Joe, there's like more than a dozen different axiomatic systems for mereology, and only in some axiomatic systems is the part of relationship defined as reflexive. So it may just be picking identifying those axiomatic systems that you feel are compatible, that treat it as irreflexive. Because I mean, the classic logic in ISM is the relationships are irreflexive.
Yeah. So there's that. Thanks for bringing that up, Kevin. That is true. There's a wide range. I just, in this particular case, just picked the one from Wikipedia, which went through and detailed other axioms. I think that they were all they're all interrelated, because you can, if you use antisymmetric, you can have it either asymmetric or symmetric. And the equality piece allows reflexivity, and also the antisymmetric piece allows irreflexivity. So when we take these apart and look at those 12 axioms, they kind of boil down to this fundamental piece. But you're right, there's a lot of different ways you can look at this. And fundamentally, because of that amount of uncertainty associated with antisymmetry, so far we don't allow that into our axioms, into structural modeling that Mary and I are working on. We find that we can use the very specific parts of the there's the primitive logical components, and then the composite ones. We can work well with the primitive ones. And the reason that we believe we can do that is in structural modeling, you're actually not trying to cover all the cases. You're actually gathering information. So if something is equal, you know that. You ask them, you ask the group, they tell you. Or if it's asymmetric, right? You ask the group, they tell you, right? So that there's no if it's this or if it's that, because you know. In the event, you will know what's going on. So that's another reason we've kind of set aside the antisymmetric right now and just address one at a time. It's either going to be one or the other for any specific situation. So in general, however, you can definitely have many, many, many different specific situations. And in neurology, if you want to have all the axioms that cover all those different specific situations, then you have to include those. So we're just looking now at this specific type, but I agree, there are other types, but we believe that they are artifacts of the compound logical groups and concepts within anti-symmetry. So, it's a good point.
Great question.
Sure.
You're talking here about the relationship between two entities, but you're not dealing with the gradient of that relationship. And I think this is the point that Wymore kept making, and I could never get Warfield to talk with Wymore. But for example, in the matrix in figure 3, what if those aren't ones? What if that's 0.9 and 0.3 and 1 and 0? Okay?
So the matrix is a logical matrix, and 1 is true and 0 is false. So it could be T's and F's.
Well, I understand that, but that never happens.
Well,
a minute ago, you said the group will agree that it's one thing or another.
Right.
I don't know where you got your groups, but I never met 3 or more human beings that absolutely would be congruent or agree.
Right. So okay. So that's a good point. And the encoding, again, within the matrix part, there are mathematics that was developed. I think the folks on the Big Island in Japan in the 70s.
Yeah, there were fuzzy logic implementations of ISM.
Yeah,
going back at least to 1981. Around that time, I remember articles coming out.
Yeah.
Yes, there were, but whatever happened to them? Where are they today?
They were done by private companies, and they didn't release it as open source.
That's right. So at this point, if we're working with ISM as our computing baseline, then it's got holes in it.
Well, okay. I think I understand what you're saying, Jack, and I agree. And so, one matrix is not sufficient to basically represent all of the density of the information required. And so, one of the things that I haven't talked about much in this series of technical reports, but that Mary and I developed prior to starting on these, is the abstract relation type.
Yeah.
And it has as many matrices as you need. And so you can have a matrix, a binary matrix. You can have a consistency type of fuzzy logic matrix. You can have as many of those as necessary to represent what you need. So we're just looking here at the basic form. And then if you need to go through and apply these other things that you're talking about, there's a mechanism there to do that. I haven't talked about it recently.
I understand that. My concern is whether or not you can therefore write a tool, a super ISM, that can help you wade through that thicket.
Well, I believe that there's a number of things that can help, but right now, I think the important part is that we're getting the information from the group, right? And when we're looking at this technique that was developed in the 70s, prior to the ubiquitous availability of network computing, we're talking about like an event. And so where we get everybody together in kind of a learning event, an observatorium.
Yeah.
So these other things that you're talking about, once we have these learning type events, we can now, with network-based computing, we can gather other information, other contextual data. We can have other things going on in the background that then we are looking at. We're saying, well, okay, this doesn't seem to adjust with this kind of observation, or that doesn't seem to adjust with that kind of observation. And asynchronously, after the event or before the next event, or you could have a series of events, you can talk with people, you can bring up the ideas. So there's a lot of support that you can wrap around this. And we've kind of done a bit of an architecture on that. And it's, but yeah, that's kind of, I agree. Those are the things that need to happen, but it's got to be kind of done a piece at a time.
And this is related to what we've discussed with Kevin. Kevin made some progress on this, or in the group here that started our second meetings, was trying to put together the landscape of factors in the modeling approaches so that this binary or Boolean-based binary approach that you're developing here is a nice, clean baseline case. But then there are other related variants that are part of the general picture that should be collected for further development, including Friedman's constraint theory, which you've talked about a few times, and other DSM methods that would make up the bigger picture. But I agree that this is a nice, clean case to be working on, but we shouldn't forget that it's within a landscape or a space of more complexity that needs to be developed in the future.
Yeah, so I think the greatest thing about this particular aspect of the complex or complexity reduction approach is that it's working with people, and you're getting people in a group learning, and it's a structured group learning process, and there's all kinds of other activities that are wrapped around this logic and this mathematics, and so that I think is important, and I think that's a good piece, and I think there's lots of design work that can be done there by, again, psychologists, organizational development specialists, people like that. Once we're getting the information and encoding it from people, do we do that once? Do we do it in big events? Do we do it asynchronously, a little bit at a time, and aggregate it over time? We can do that now with computing. Do we do both? Do they have different aspects, or was one more valuable than the other? But once we get a structure like this, based on information from an organization, then there's other aspects that can be applied, and the evolutionary programming pieces where, before I started on the logic piece, the binary logic piece, did quite a bit of work on the evolutionary computation aspects. And what that is, and what this is, it seems to me, when you're working with groups, it's discovery. You're discovering the problem. Then, when you get into the other aspects of things you want to do, you're designing a solution. And solution design is large-scale search. So you start going through the large-scale search of evolutionary programming, all these different types of techniques. The fellow on the science list the other day was talking about many of these different techniques, looking at different aspects of a system structure or a design. And all those can be done in the background. You can aggregate the value set up to the human decision makers, and that's all possible to be done, right? But this is just kind of a component of it. So let's see. Okay, back to the part of depicting rats. And just for a point, if you only had the fruit bowl and the morning meal, that would be a linear piece, right? Because you just have one fruit goes to fruit bowl goes to morning meal. That's it. That would be a single threaded logic piece. So, but it's not. But it for the components that we have, right? We have, like many more components in the morning meal, so it's multi-threaded. Right? It takes and composes the morning meal is composed of all these other things. But we also see that a cup is not part of the cereal bowl, and fruit is not part of the coffee drink, so it's not global, right? It's local. There are local relationships here that are important distinctions. Of course, here's the part of without the reflexive piece, and again, as you can see that the really taking the ones away really doesn't detract any information from the structure of the system. And what I've designed these matrices in the binary part to have the ones in the asymmetric configurations in the lower triangular. And so to do that, then in reading it depends upon the graphic of how you read the natural language relationship correctly, and we have an example in this paper. But the idea now is to say, okay, if I look at this, I know that it is a local relationship because there are zeros in the lower triangular. And if they're all ones in the lower triangular, then it's a global relationship. And so there's some conventions that we've developed that allows us to start getting the big picture, more or less, from the matrix. And we look at the matrix and we can start assigning these things to it. So, come up with irreflexive for precedes, no event precedes itself, asymmetric, A precedes B, then B does not precede A, and transitive. And so these are fairly simple types of natural language tests that you could, pass out and ask people to answer the question, to say, about the objects that they are discussing or evaluating. You don't put the irreflexive, symmetric, or transitive, but you ask these natural language questions that represent these functions. And here, of course, is the way to read the precedes matrix. And of course, make the argument that if you have precedes and it's reflexive, you come up with nonsense answers. So we suggest that you use irreflexive. But you can see here, again, that this is now a local relationship because of all the ones in the lower triangular. I mean, it's a global relationship because of all the ones in the lower triangular, the lower triangular portion. So it's a global relationship because the lower triangular part of the matrix is filled with ones. And you see the same thing here without the ones on the diagonal. Global relationship. And then this allows the inference. The type of inference that's supported by the EMU ISM software. But what this turns out to be is an order. And so if we're interested in reducing the amount of resources necessary to order a system, or reduce the amount of questions, reduce the amount of time we're engaging people, then the using inference really reduces the number of questions you have to ask in these cases. And it's reproducible. The cases we found that were global type of relationships, you were able to reproduce those using the existing software pieces. So looking at this and thinking about it, we've kind of, again, refined and restated the construction rule for a system, as a system is a relationship associated with a collection of at least two distinct objects. So this helps us a little bit with dealing with the idea of reflectivity only being assigned to one object and the idea of a part of, and with only one object, right? Or a part being the whole. We kind of skate around that by changing this definition, by refining this definition, and it begins to, within the structural integration modeling piece now, these are rules and conventions that we can use to start making a set of idioms so that when we work with the prose and the structured graphics and the mathematical matrices, we know we're reading them in the same way and they have a way that they should be presented. Nick?
Joe?
Yeah.
Just make a comment on both cases you just talked about.
Yeah.
With part of him precedes having the asymmetric property. To do that with Warfield's software and also Christakis' software and what is now Lauwers' software, you had to ignore questions that cross the diagonal. So the software actually wasn't built to do a part of or a precedes relationship or relationship that was asymmetric, because it's always looking for cycles. And the software will eventually always ask for the relationship between two things in both directions. So like an adjustment to the algorithm would be if you're modeling a relationship that is asymmetric, then don't ask about symmetric. But right now they do, because it's looking, in general, it's looking for networks of a general type.
Well, okay, that's interesting. Because the two examples in the handbook are, well, there's actually three examples in the handbook. One is heavier than, or weighs more, right? Which is global, right?
Yeah.
And I worked through those answers and inputs and so forth. I don't really remember having to ignore anything. So I'll have to go back and look at that. The other one is the, of course, is in classification. This class is the same as, right? Or it's the same category as. And that's equals, that's reflexive, symmetric, and transitive. So those two parts, actually, you can combine them to have a kind of a partial order. But if you look at the handbook in the back, where they have things that are ordered, right? When they have groups of equal value in the same position, they make that a linear order. So it's kind of interesting, and that's where basically I got the idea that you really just could combine classification and a strict order, and you would have a partial order, and you wouldn't have to deal with the other logical components. And so far, then it's worked out. But I'll go back and check that out. I don't remember that happening, but you have a lot more experience with it than I do, so I'm sure you're right.
Also, while this graphic is up, also add response to Jack's point about gradients. When we use the software to fill in this matrix and compute with the matrix, we keep track of the votes in a group. So if there's 20 people in a group and a dozen of them say yes, they think a relationship holds, we track that as 12 yeses, 7 no's, and 1 abstention. And we keep track of those. And so if we want to, at the end, demonstrate the weighting of the arrows, we can do that in, just by changing the size of the of the arrows is one way to do it graphically. But what's the critical point is you have to decide what your decision rule is. So, and I've been in events where simple majority would make a one meaning yes, there is a relationship. But I've also been in events where we wanted very strong agreement on the existence of relationships. So it had to be at least 3/4 of the people, and the decision rule was 3/4 had to say yes for there to be established a relationship. And I've also been in events where it was a very loose, kind of fuzzy, futuristic thing, and we wanted to be sure we caught relationships. So the decision rule was a quorum if at least if even if only 30% of the people said yes, there's a relationship, we would record the relationship. So we had different decision rules, and we could. So we knew what was the crossover, what was the threshold for a 1 versus a 0, and then we could come back and just manually show that. But we didn't. It didn't become a persistent practice of showing the weightings afterwards. But right now, that information, those voting records, are tracked automatically in the Logosophia software with Dietrich's implementation up in Michigan. So he's not doing anything with it, but he is tracking every vote because people vote using clickers or their phone. Anyway.
That's an interesting thing to do because number one is the convergence in social theory. The magic number is 70%. If 70% of us agree, then we all buy in. So that's one little rule that it turns out to be informative. But another thing that you could be doing with the data you're collecting there is you could be computing or identifying well, now I've lost the word.
That's okay. It's all right. I'll lose them all the time.
The clan think and the group think.
Yep.
Because in each one of those questions, it's likely that the people responding are beginning to find one another and band into belief systems that amount to clan think and group think. So I think it's possible, therefore, for you to process the data you're collecting, retrospectively qualify the conclusions of ISM relative to false positives and false negatives.
Yeah.
And as people are beginning to find out in machine learning and artificial intelligence, when they use all those big matrices to arrive at a conclusion, they do not compute the probability of false positives and false negatives. And in the autonomy world, those are called bugs.
Yeah, it can be a real issue.
Yep.
I mean, those are all really, really good points. And
Kevin? Yeah, I was going to say that I know this is this uses more resources, and one of the goals is to make the process more efficient. But when you say that you have these different decision rules on whether a relationship, whether to include a relationship, whether it exists or not, a good point from Jack talking about false positives and false negatives, because can you assume if the relationship if people do not say the relationship is there, then you can positively assert that there is no relationship? Or, are you making a closed world assumption about anything that is not included is absent? Or, so the false positives, false negatives, and closed world, open world assumption need to be brought in together with the voting rule. That's a good elaboration. It doesn't. I was trying to figure out if that relates to Joe's classifying the logical properties by 0, and 1 element, 2 elements, 3 elements. Anyway, good stuff. Go on.
I think when you talk about whether the judgment of the group as to whether a relationship exists, and they assert it doesn't. And the question is, well, does it really? I think consider what it is that you're modeling. If you're modeling intentionality, if they say it doesn't because it's not their intention. If you're trying to model like a natural process, like discovering a new physics of some new phenomena, and a bunch of experts get together and they say, we don't think it exists. Yes, they may be wrong with respect to some system that is expressing that relationship, and the experts just don't see it. But if you're modeling intentionality of the group, then if they say they don't have the intention, unless they're lying, you have to accept that that's not, their intention is the relationship doesn't exist.
Right. Well, in that case, you're introducing another wrinkle when you say that that a quorum could decide that the intention exists when it, the rest of the people don't hold it. But I was thinking more of influence, for example, where if the group fails to include an influence relationship, is that affirmatively saying that there's independence between the factors? Is the absence of the inclusion of the relationship a positive assertion or not? Anyway, maybe we should let Joe get back to finishing his.
It's a good question.
These are really good. These are really good comments and really good insights. And I think that might be a good topic for 2 weeks from now, someone, or maybe next month, because Mary and I will be hosting, but we won't be doing the content for those two. And maybe just we're getting close to the end. I've got about 7 minutes left. What I'd like to do is kind of talk about the offer that Janis made for Cognoscope 2. And I briefly went and took some time and kind of searched, and I couldn't find Cognoscope 2 on the link that he provided. There was a Cognoscope 3, but I couldn't find a Cognoscope 2. And the other thing was that didn't really get any feedback from folks that wanted to actually go through and test the functionality of the software. So if there's people that are interested in doing that, then that might be something that we could look at as a group. And I don't know, Kevin, would you be interested in demonstrating that software or talking about it?
Normally I would be, but my computer died.
Oh, okay.
And right now I'm talking to you now. I'm my wife's computer, which
Okay.
is it's not set up for that.
Alrighty then. Well,
But I think what Yandis has indicated interest in to collaborate on what you want to do.
I think it would be good to.
He doesn't like to meet with us on Skype because our meeting time is right during his dinner time on Saturday nights, and he usually goes out to eat somewhere.
Okay. Well, that's that's so I understand that that can be an issue, and
But
so- go ahead.
he has a lot of people that work for him, and if we can outline exactly what you want him to do, he can hand it off to one of his people in the software group.
Well, I guess his offer was that he would provide a copy, an evaluation copy, or a copy for us to test Cognoscope 2. And I couldn't find it at the address he sent.
Okay.
So, and then there were other people that expressed an interest in that. I know Steve Crane is looking for software to use. He's complaining about the ASM old software dying. And so the idea would be to get practitioners and people that are familiar with the software and the software functionality to get together, kind of, if we can have access to it or get copies of the software, then do a test plan, do a behavioral, or what should the software actually do, what functions do we want, right? And then kind of talk about it a little bit. So there was this Cognoscope 2. It was a version of Cognoscope that was designed and limited to 10 elements or something like that, and it had a time limit. So it was an evaluation copy that was done especially for people in courses. Okay.
I think that's what he was referring to. And the woman that had set that up left Giannis's organization.
Okay.
She went to work for a bank, I think,
Okay.
to make more money. So I don't think there's anyone in Giannis's organization that has a handle on how that was set up. So if you're having trouble getting a response from them, that could be why.
Well, I just went to the website and I searched, and all I could find was a Cognoscope 3 thing. And so it just wasn't. Maybe I need a more specific link or something.
Yeah, I'm not sure if I'm not sure if the Cognoscope 2 was online or not. He might have just made a mistake in which link he gave you. But
okay, so
I'll talk next time I talk to him. I'll ask him about that.
Another thing to consider is that Dr. Pizzarello has offered that if you have a tool that you are using, but you're not real sure what it's doing, and maybe even it has a latent bug, Tony will go through that code and tell you where all the bugs are.
excellent.
I'm not going to sign him up to a year's project, but
I think
ISM or Cognoscope or one of those, he'd be willing to do.
so I think the idea would be, if there's people that are interested in evaluating the software tools, the closed source software tools that exist now, then we should figure that out and see which ones are available. So it's I'm going to keep, of course, Mary and I are going to keep working on our open source, and the evaluation of the closed source tools functionality and what they do would help us in setting requirements for our open source stuff. So
Right.
it would be an interesting exercise. So we have about a minute left. So is there anyone going to step up for 2 weeks from now on what would that be, the 15th? Okay. Any topics for 2 weeks from now? All right.
I'd be interested in hearing Jack's experience over the years with Dr. Warfield. I haven't had the opportunity to talk with Jack before, and I think we should try to keep the oral history alive a bit.
Well, I was just being quiet there because September's a terrible month for me. I would be happy to do what you're suggesting. And in fact, probably could even get Professor Bloom here at ASU, who was John's understudy for several years.
Yeah.
And maybe even Staley from Ford, who actually used all of John's stuff.
Yeah, I know Scott.
Yeah. So Scott seems to be pretty strongly retired, but maybe if we surrounded him, we could get him to,
Okay.
to
All
get
right,
us.
that's great.
Joe, did you say that you weren't going to meet in October?
No, we're going to have, well, Mary and I are not going to present the material for October. We will manage the hookups and do the computing and everything. But we're looking for someone else to have the content for October.
Well, maybe Jack could see if he could arrange this discussion for the first, that would be the 6th of October.
I believe so.
Yeah, that would be great.
Well, thanks for volunteering me, Janet.
Well, I moved you out of September. That was what you said.
Thanks a lot. Yeah.
For those who are attending the next one in 2 weeks, which would be the 15th, I would suggest that one of the things that we could add to, or as part of the discussion, is distinguishing between group learning, which is what ISM was really set up to do, I think, in large part, and clan think and group think. So where do you and how do you draw the lines between what you think is group learning versus group think and clan think?
Oh, there's a little equation in which you take the responses from N people and process them, and you can if the yays are like 90% and the nays 10%, there's group think going on.
All right. Well, I think we're close to the end of this particular event. So far, right now, we don't have anyone stepped up for the 15th. I'll wait for some people to indicate that they're interested in doing that. If they're not, they'll just cancel it and go from there. But we'll wait a week, 10 days, something like that, give people time to respond. So. Thanks everybody for attending. We'll look forward to seeing you in a future event.
Okay, bye-bye.
Thank you for doing all this, John and Mary.
Yes.